So welcome back. So one thing I forgot in the previous video, types of the slow fast pattern. So there are not multiple, there are three types of variations for this. One is speed difference. Okay, so in this the slope pointer might be might be walking at one step, but fast pointer might be moving by two steps. So there is a difference in the speed, and this kind of patterns is mostly used in the cycle detection. Okay, and or you want to find out the middle element of a given array. Okay, so are finding the middle element. Another type of two pointer, slow fast pointer is there. So that we call it where speed is same. Speed is same. So normally the use case of this particular type is happens after the speed difference. So like using the first approach, you reach some conclusion, you reach it at some condition or conclusion is coming, then you are going to apply this same speed pattern. So in this, what happened, as the name suggests, slow and fast both are moving with the same speed, like one step or two step, whatever. Okay, so this mostly use finding the start point of the cycle, finding start point of the cycle. Okay, and third problem type of slow fast pattern, that is transform structure. It's a little bit advanced. So transform structure. In this, what happens here, we are going to convert any problem into a cycle. Okay, so convert the problem into cycle. So like suppose I want to find out the duplicate number. Okay, so duplicate number, to find duplicate number, it must be a cycle. So if like suppose 1 2 3 2 is there, it says number is duplicate. If you convert this problem in a cycle, then only this approach is going to help, because it says like when suppose I am visiting this, if 2 is already occurred, I will mark somewhere I have visited this number. Again this 2 is coming, then it's a duplicate, right? So in this way, first we will transform the given problem into a cycle, then use this slow fast pointers approach. Okay, that is fine. So now let me give you example and one intuition, like how slow fast pointer used to find the cycle. Okay, suppose I'm having one linked list. Okay, and this is my number 1 2 3 4 and here is 5. Okay, it is something like that. My slow and fast pointer suppose is here. Slow, anywhere you can start point, you can suppose, let me take 1 is the starting point, just to keep it clear and non-confusing. Suppose my slow and fast pointer are pointing to this. Okay, so slow will be moving one step, and a fast pointer will be moving 2 steps, right? Remember that. I want to show you like when the cycle will come. Okay, so now slow will be here in one cycle, and the same moment fast will be here, right? Then slow will move here and fast will go here. Okay, then slow will again come here, then fast will go here. See this. Okay, again slow will go here because slow is moving by one step, then fast will come here, 2 step, right? Then again slow will come here. Now the fast will at the same point now. So what does it mean? If there is a cycle, then there will be one case where slow will become the fast. So that called meeting point. So if meeting point you are able to find, it means you can surely you can say there is a cycle. So this is a cycle detection technique. Okay, so hope you understand that. Okay, so let's discuss about the program for this, like how this is going to work, because I have given one idea, right? So cycle detection. Okay, so problem statement is that given a linked list, determine if it contain a cycle. Okay, so here we are considering the linked list. Remember that a linked list property I already have explained you. Okay, so I'm assuming that you know like what is the structure of the linked list, a node of the linked list. Okay, so imagine you are working on a system like task scheduler or some order processing pipeline. Okay, so each task point to a next task, right? So step by step task, you cannot jump from here, you have to come by this way. Okay, so this kind of scenario actually where I can use this. So to find the detection, like how do you think there is some cycle, how you are going to think there is a duplicate or there is a cycle in this path? Okay, there is only one way. You traverse each and every element or node of this input and store in a hash. Okay, some hash set. If node is already exist, it means cycle found. Correct? If this is 1 2 3 4 5 6, this is again 2, so when you reach here again you are going to keep in the set, and then you're going to say this record is already exist. It means you can say there is a cycle in this loop. Correct? So why I mean, this is one solution, and because in a cycle you will eventually revisit a node, so that is the baseline. Okay, so like if I give you one more example, suppose A, B, C, D, again B, cycle is there. How are you going to write a program for this? We are going to visit A, store, visit B, store, visit C, store, visit D. Till here it's okay, we didn't get any sign of cycle. Okay, but when this B is coming, it's already exist, it means cycle is there. Correct? So problem is that it's going to take extra space of order of n. Okay, because for each node you are keeping the memory, right? For each node wasting and storing in some other place. Okay, so this is not optimal solution. Okay, so what should be the optimized approach? For this we are going to use the slow fast pointer approach. Slow fast pointer approach. Okay, so we know that slow is going to move by 1 step and fast is going to by 2 step. Okay, so intuition is coming like things like a race track. So if there is no cycle, fast reaches end, right? But if there is a cycle, fast will catch slow. So this is the only baseline that whole algorithm is made on. And this algorithm was also known as some other name. It's called Floyd cycle detection. sometime by this name also you get the problem. So fluid cycle detection. Okay. So intuition is that when I'm doing A, B, C, D, E, right? This is the element. So both pointers are here, slow, fast. So what I'm going to write, I'm going to find out, here I'm going to write the slow visited node. This is the fast. So slow, it will move slowly, A is to B. Then how the fast will go fast will go A to C, right? Slow is here, slow is come now here, B to C, and fast will go C to E, right? Correct. Now suppose one more an example I have to, since I need a cycle, so let me give you like E to C again, something like that. Okay, so slow will from C, slow will reach to D, and fast pointer from E to again is going to be fast, so it's going to reach D, right? It was on E, then again is going to E, sorry, it is going to be at E. Let me erase it. So from E, one step, okay, then second step. So fast will go from E to C, no, E to C. So from E it will reach to D, correct? So my slow is pointer as D, my slow will reach here, so D to E, and what the fast for D, it will again go to C. Then from E my slow pointer will reach to C, and my fast pointer from C it will reach to E. Okay, now from C the slow pointer is going to again D, and my E pointer, fast pointer, is going to reach D. So now here slow pointer equal to fast, they are meeting at the same point. If this is happening, so eventually this is going to happen, so we call it there is a cycle in the given data. Okay, so let's see that, like how we can write a program for this. So just one prerequisite that you have to remember, like what is the linked list structure, I mean node structure. Okay, so let me repeat it again, though I have talked about in the previous video. So I'm having one class node, and node is having two variable, one is int value, second is node itself, but it's having a reference of next. Okay, that's it. So when we are going to compare or find out, we are going to compare this. When I'm moving in the direction, I'm going to call this for the next pointer. Okay, so let's see Java program for this in the next video. Okay.